So as you're taking a lick of your triple-decker ice cream cone, you're thinking, man, it would be nice to calculate the surface area and volume of this cone. If only I had some sort of understanding of the formulas necessary to perform such a complex mathematical computation. Well, if you're thinking such specifically nerdy mathematical thoughts, you are in the right place. In this video, I'm going to show you how to calculate the surface area and volume of a cone.
Alright, so I'm going to give you two formulas here. The surface area for a cone is pi times the radius of the circular base times the slant height, and then we add pi r squared. So if you think about a cone, this piece here is the circular base of the cone. This pi r squared, that refers to the area of that circle. The rest, the pi rs, that refers to the area of this lateral surface, pi rs. And s here, that's the length of the slant height of the cone. And that'll either be given in a problem or you'll have to solve for it. You'll see an example of that in this video. Okay, the formula for the volume of a cone. If you picture, for instance, this cone, if I place this cone inside of this cylinder like so, you can see that the cone occupies most of the volume of this cylinder. It actually turns out that it's 1/3 of the volume of the cylinder. So that's where the formula for the volume of a cone comes from. It's the same as the formula for the volume of a cylinder, which is the area of the base times the height, but it's just 1/3 for a cone. R squared, your R is the radius, so that's the radius of the circular base here. Remember, the radius is half of the diameter of a circle, and you're going to multiply by the height of the cone. So that's from the base right up to the tip of the cone. Okay, two formulas for you. All right, so first example here, we're looking at a cone shape. We're being asked to calculate the surface area of this cone. Notice that we're given the height of the cone and the radius of the cone. Taking a look at our surface area formula, you'll see that that doesn't actually give us all the information we need. We need this S, this slant height, which is this portion of the cone here. We're not given that measurement in this cone, so our job is to first find out what that slant height is. Now, if you take a look at this diagram, there is a right triangle involved here. The height goes from the center of the cone to the tip of the cone, so we make a right angle triangle. We have this height and we have our radius, which leaves us all of the sides except for the hypotenuse of our triangle. So you're thinking, well, if I have two sides of a right triangle, there is a tool that you can use to find the length of the third side, which turns out to be the hypotenuse of the triangle. Well, Pythagorean theorem might work. It's a right triangle, we've got two sides, we're looking for the third side, so we can apply Pythagorean theorem. So remember, we do not have the hypotenuse, that's what we're solving for. So we're going to leave C as our unknown, and we're just going to sub in either A or B or A or B, depending on which you'd like to put where. Remember, it doesn't actually matter. A and B are just the other two sides of the triangle that are not the hypotenuse. Okay, so if I substitute those two values in, I'm going to do a little bit of calculator work. You'll see that I end up with 73 on the right, but that is the value of C squared. Remember, the hypotenuse is just C, so I take the square root of both sides and I end up with 8.54 centimeters. So that's going to be my slant height. So now that I have this value, I've got enough information to substitute everything into this formula to solve for the surface area of this cone. So my next line will look something like this. My radius is 3. I've got my new slant height. I'm subbing in my radius here as well. Now this is going to be a little bit of calculator work, and if you just multiply these three numbers together, add pi times 3 squared, we end up with 108.76 centimeters. Now, if you didn't get this value, odds are you used 3.14 for pi. When I calculated the surface area, I used the pi button on my calculator. Okay, so that's the surface area of my cone. The last example for this video, we're going to look at the volume formula, except this time we're going to do something a little different. We're not just going to solve for the volume. In this case, we're being told that this cone has a volume of 210 centimeters cubed, and it has a diameter of 8 centimeters. We're actually being asked to solve for the height in this case. So you're thinking, well, I have a formula. H is not by itself. You can actually algebraically rearrange this formula to solve for H. So that's what we're going to do. We're going to first of all substitute all the information that we have. So we know the volume is 210 centimeters cubed, so I can put that in for V. Pi, we're going to leave. Our radius, we're not explicitly given. We are told that this distance is 8 centimeters. The radius is half of the diameter, so our radius in this case would be 4. And we don't have our height. That's what we're solving for. So if we substitute what we know, we end up with something like this. Okay, so our goal is to now get H by itself. Now there's a lot of stuff going on here. We've got a 1/3. This fraction's probably troubling some of you. I don't really like fractions in my equations. We're going to get rid of this fraction. Remember, this is 1 divided by 3. So if you want to get rid of division in your equation, then I multiply this side by 3. This fraction and this 3 should cancel out nicely. But remember, this is like a scale. I can't just do it to one side. I also have to multiply by 3 on the other side of the equation. That gets rid of my fraction nicely. So that cleans it up a little bit. I know 4 squared is 16. So I just multiplied 3 times 2, 10. I got 630. Okay, this pi is multiplied by 16 times h. So to get rid of these guys, I'm going to simply divide both sides by pi and divide both sides by 16. And that should give you a nice value for h. I got 12.53 centimeters. You might get something a little different if you use 3.14 instead of the exact value of pi, but in the end, you should get something around 12 centimeters, and that should be the height of your cone. So a little bit of a more difficult example, definitely some algebra involved here that some of you might have a hard time with, but just think back to the rules for algebra. You can't do something on one side, you gotta do it on both sides, and you can rearrange equations by simply performing the opposite operation.
If this video helped in any way, feel free to like and subscribe for more mathematical chaos. As usual, thanks for watching.